It is said that 80% of a data scientist's work is spent wrangling and cleaning the data. And if that data scientist is working with time series data, they can probably expect kind of the same percentage. Rarely is time series data available to us in a way that is easily plottable or that we could model really easily. Based on our question of interest, we usually need to do something, clean the data, wrangle it, manipulate it in some way so that we can easily use it. So as an example, let's look at that taxi cab data. And if we recall, we'll come over here to R. In the TSWG package, we have a data set called yellow cab preclean.ts. And if we look at that, it's a beautiful data set of 2 years of this passenger data from January 2019 to December 2020. And with that, we can plot it, we could end up forecasting it, we can manipulate it and use it to model pretty easily. But it didn't come to us like that. So what we'd like to do is start with where we got the data from. And we got it from this New York City curated governmental website. And if we click on that, we see we've got right here, we have data and research, and that's where we'll go. So we click on data and research, and then over here to data. It looks great. And we'll come down here. There's tons of data. We'll look at aggregated reports. This is just New York City has done a great job of making this data available and curating it for us. But I'll look at aggregated reports. And again, tons of data to look at here, lots of reports. We'll go down to the monthly data reports, CSV, and we'll get this. Based on your operating system, based on your browser, it may not look exactly like this, but the idea will be the same. So I'll go ahead and right click on this and save page as. And what you'll see is possibly, I've got in mind 2 options: web archive data, which will save images, and it won't exactly save it in the CSV format. So I'll go to page source, where it says saves only the source text of this page. Again, yours may not look exactly like this, but look for the options that will take you to saving this as a CSV file. And so I'll go ahead and save this. Notice I'm going to my downloads. You can save it wherever you like, and I'm calling it Data Reports Monthly. I'll go ahead and save this. It's saying, hey, do I want to replace it? Because notice Data Reports Monthly.csv is what it's trying to save it as, and I've already done this once. So it's going to overwrite it. If this is the first time you're doing this, it of course won't have anything to overwrite. So I'm going to replace it, and we'll come back. So next thing to do is to bring it into R. And so that is what we're going to look at here is I'll do notice that's New York cab raw data, and use our handy dandy CSV function read.csv. And let's get off to the races here. I'll go ahead and do that. And it's going to notice that I don't have a separator explicitly saying that separator is a comma. It's because it's the comma and it's the default. So I'm going to go to this, go to my downloads, and here we'll see Data Reports Monthly CSV. I just downloaded that and overwrote it. So then the next thing I like to do, it's almost a reflex of mine, is to print out the data. Make sure that I brought it in at all. Make sure that it's exactly kind of what I think, a little bit of a sanity check. And we can see here, we've got a lot of columns, right? New York City is providing us a lot of data about each of these trips and about the aggregated information of each of these trips. So I've got year, which is actually year and month. I've got class, I've got trips per day, and I've got a whole bunch of other information that for this question of interest and for this data set that I'm trying to build, I don't necessarily need. For other questions of interest, I know that it's there and I might be able to use it one day. But regardless, for now, I would like to take this data set that we've got and make it a smaller data set that's more relevant to the question of interest I want to answer. So all I need is year, class, and trips per day. And so in order to do that, we are going to look at we're going to use the dplayer package. And I highly recommend, if you're going to end up using R a bunch, you may already be really familiar with it. It's in a package called the Tidyverse. You can download dplayer explicitly, or you can use it in a package called Tidyverse, but highly recommend it. It's a great way to, and becoming kind of the standard way of wrangling and manipulating and filtering and selecting data. So I'll go ahead and kind of show, I've already loaded it here, but if you install and load a library called Tidyverse, again, you may have already used it, you'll end up just loading that in there like that. I've already loaded it, so that's all it's going to say, but it actually loads a bunch of packages as part of the Tidyverse. So one of those packages is the dplayer package, and in there, there's also one called the magritter package, which gives you this little pipe function. And so whenever you see the pipe function, you can think of just saying "and then." So let's check it out. So I'm going to take the New York cab. I'm going to make a new data set called New York cab new. And I'm going to take the New York cab raw data set that again has all of these columns. And we'll just see how this works now. And then we'll kind of just use it, remember that as we go forward and use it a little quicker. So New York cab new is equal to the New York cab raw. And then with the New York cab raw data, and then we're going to select year, class, and trips per day. It's that easy. And then I'll print out the head just so we can see it. So that's all we need to do. And I'll come back over to R. Let's give ourselves some room. Again, we're going to do that. And notice now we just have year, class, and trips per day. So easy. So now what I'd like to do is just use the, notice if I come back over here, I've got yellow, high volume, green, FHV, limos. All I want is the yellow cab data. And so all I need to do is filter it now. So the next thing I'm going to do inside of, again, the tidyverse inside a dplayer is we can filter. Notice that last one was select. That'll select columns. Filter filters rows. And so I'll do this again. So this is New York cab new. And then I'm going to override it. New York cab new equals the New York cab new. And then filter, and I want license class equals yellow. And I'm going to let double equals for conditional equals non-assignment. So I'm going to go ahead and do that. Again, just playing around with this is the best way to become really comfortable in how to do it. But we do that. Notice now we've got year, class, and trips per day, but all of these are yellow, and that's just the head of the data set. Awesome. We've done so much already in such easy code, very easy to read code, very easily reproducible. And the next thing we want to do is we'd like to one day use this to plot and to model. But we'll see it's got a comma in it. And that's so, a lot of times that comes up because if we look at it closely, we see it as a number. But R, if we look at the class of that column, R sees it not as a number, but as a character. And that's a problem because functions like in TSWGE, functions in other packages that are expecting numerical data, it will choke on that. It'll say, hey, this is not an invalid type. So what I'd like to do first is take out the comma, right? And inside there, again, there's a lot of functions for text manipulation, but one of them being the sub package. And so the sub function. And so that's saying, hey, find commas and replace it with this. So the first argument is what you're looking for. And the second argument is what you're going to replace it with. So cleverly, I'm going to take a comma and replace it with nothing, which is effectively deleting the comma. And so we'll see that. And then once we have that, we'll just have a character that's just numbers. So I'll make it as numeric and it will take out the comma. And then it will reclassify, recast that character vector, that character array as a number because it'll be composed only of numbers. So play around with that. Once again, you'll see you'll get numbers similar to these down here. I'll come over here to this and we'll verify that's what we're doing. So we'll run all of those and notice there's no more commas and they're all numbers now. Okay, and if I was to look at that and let's say that I say class no comma trips, it'll say that they're numeric. So now I've taken that big data set, whittled it down to 3, and then taken those 3 and taken that one column and then changed that, took out the comma from the trips column, made it a number. And what am I going to do next? We're going to reverse it. So right now in this data set, you'll see that it goes from the latest ones to the earliest ones. And what we'd like to have is the earliest ones to the latest ones. And so all you got to do there, and this is pretty common function, actually it's so common it's in the base package. So this just comes in base R, this reverse. It just takes all of the array and flips it around so that the last ones are first and the first ones are last. So when we do this, we'll come back around. Notice this is 111 up here and 473, 479, 376 down there. When I do this, it flips them around. So there's the 479, 376 and the 111, 638 right there. It has just flipped it around. These are the earliest ones now, and these are the later ones. So great. So what is happening next? What we'd like to do next is, of course, make our TS object. And so this is new cabs, new TS is equal to no comma trips, which is just a numerical array. I'd like to start those at 2010, start at January of 2010. And then we will make a window. We'll cut those out. So it's got this big data set that starts at 2010, but then we'll say, hey, let's just start at 2019 and go to December 2020, and we'll have it. So we've got those, and we will come here. Again, all of these are data, but they start at January 2010, and they go on till the latest data point that we have. So this right here is saying, hey, assign that 479376 to be January 2010. That will go all the way as far as it goes. And then we'll, after that, we'll have that, and we'll say, hey, start at January 2019 and go until 2020 of December, and we'll have that. So we have that, and we end up with 247,315 all the way to 47145. That's where, right about here is where COVID hit, and the trips really started to die off. But that is what we see right here. It's the same data that we see pop up right there. And then finally, what we can do is plot it. And plotting is really what we should always do with our data, because picture's worth more than 1,000 words. But that is a very similar plot to one we've seen before. We can clearly see the big dip where COVID occurred, and we are set. But we have really come a long way from ingesting the data in this form, and then really just grabbing this trips per day, turning it from a vector of characters into a numerical column, and then getting out our TS object in the end. So great job. Fantastic work. And get out there, start wrangling and cleaning, and then you can model and plot, and I'll see you next time. Great job.